Welcome to the deep dive. Today, we're going to be looking at the world of secure software development.
Yeah, the stuff behind the scenes that most people never even think about.
But it's running everything, right? Everything we do online.
It really is, and it's a lot more complex than most people realize.
Exactly. And to help us unpack all of this, we've got some excerpts from Secure and Resilient Software Development.
Great resource for sure.
And this deep dive will take us through, well, everything. Programming, best practices, common vulnerabilities, and even how to think about security differently depending on if we're talking about, say, embedded systems versus cloud computing or mobile apps.
Yeah, all very different beasts.
Okay, so let's jump right in. One of the first things that jumped out at me from the book was this idea of catching security flaws early.
Yeah, the earlier the better, right?
Right. They actually cite research saying that fixing a security issue during the design phase can be 30 to 60 times cheaper than fixing it after the software is already out in the wild.
It's a huge difference. It's like, catching a typo before you've printed 1,000 copies of a book versus having to go back and reprint everything.
Okay, so let's say you're a developer, right? You're racing against deadlines, trying to get this software out the door. Why should you care about catching these things early?
Well, I mean, for starters, because one little vulnerability can have this massive ripple effect, right?
Yeah.
It's not just about your software. It can impact the entire system.
And when you say system, what do you mean?
I mean, well, think of like a website, for example.
Sure.
If there's like even just a simple form that's not properly secured, that could be all it takes for someone to compromise an entire database.
Wait, so you're saying even something as simple as a form can be a security risk?
Absolutely.
Wow. So what can developers actually do to protect against that kind of thing?
Well, it all comes down to input handling techniques.
Mm.
The book really stresses this idea that any data that comes into your software, no matter how harmless it might look, you have to treat it as potentially dangerous, potentially malicious.
So it's like you're always assuming the worst.
In a way, yes,
Mm.
because you never know.
Yeah.
Right. And that's why things like validation and standardization are so important.
Can you break those down for us a little?
Sure. So validation is basically making sure that the data is in the format you're expecting.
Like, if it's supposed to be a phone number, making sure it actually has numbers in it.
Exactly. And then standardization takes that a step further by removing or encoding any characters that could be used to, like, manipulate the system in a harmful way.
Okay, so it's like a double layer of protection.
It is. The book actually gives this really interesting example about how attackers exploited a vulnerability in Microsoft's ISIS web server, and they did it using Unicode encoding.
Oh, Unicode. That's how computers handle all the different characters and languages, right?
Right. And so the attackers were basically able to make certain characters, like forward slashes and backslashes, look like their Unicode counterparts.
So the system was tricked.
Exactly. They thought these were totally harmless characters, and because of that, the attackers were able to bypass security measures and gain access.
That's both brilliant and terrifying.
It is. And speaking of encoding, the book actually talks about how these complexities, especially when you're dealing with international languages, can create even more vulnerabilities.
Oh, wow.
Yeah, they highlight this case with Google where their system was accepting UTF-7 encoding instead of UTF-8, which is the standard.
I'm assuming those are two different ways to represent characters.
Yes, exactly. And because the system wasn't set up to handle both correctly, it created this opening for attackers to inject a malicious script, which led to a cross-site scripting attack.
So again, it's like something that seems small, almost like a technicality, can have these huge consequences.
Absolutely.
Okay, so moving on, I want to dive into some specific types of attacks. The book mentions a few of the greatest hits of the hacker world.
Yeah, the class.
So let's start with buffer overflows. What are those all about?
Okay, so imagine you have a program, right? And it's trying to store data in a buffer, which is basically like a temporary storage container.
Okay.
Now, a buffer overflow happens when you try to stuff more data into that container that it can hold.
Like an overstuffed suitcase.
Exactly. And if an attacker can deliberately cause this overflow, they might be able to overwrite some of the memory next to the buffer, potentially even injecting their own malicious code.
So it's not just data spilling out, it's potentially dangerous instructions.
Right, exactly. And the book even provides a simple code example in C++ Wayne to show how this can actually happen.
Okay, so buffer overflows, check. What else?
Another one is, well, it's called OS commanding. And basically what happens here is attackers manipulate the input parameters to trick the application into running commands.
So it's like disguising a command as something harmless.
Kind of, yeah. Like, imagine you have a web application with a function that's supposed to display information from a file, right? An attacker could manipulate the input so that instead of pointing to a file name, it points to a system command. And that could give them control over the server.
So it's like using a harmless-looking request to sneak in something dangerous.
Exactly. And then, of course, there's cross-site scripting, or XSS.
I feel like I've heard of this one. Is this the thing where, like, you're browsing a website and suddenly all these weird pop-ups appear?
That could be a sign of it, yeah. Basically, attackers inject malicious scripts into websites, and they can use that to steal information, like cookies or session IDs, or even hijack a user session entirely.
Hold on, cookies. Those are just little text files, right? What's so dangerous about them?
Well, cookies can store sensitive information. Things like session IDs, which are basically like temporary passwords that let you stay logged into a website.
So if someone steals your cookie, it's like giving them the keys to your account.
Yeah, it's kind of like that.
Not good. And what about SQL injection? That one always sounds so, like, hacker movie-esque.
Yeah, it's a classic. SQL injection targets applications that interact with databases, which is pretty much any website where you log in or search for something or submit information.
So what's the problem?
Well, the problem is that if the application isn't carefully designed, attackers can manipulate the SQL queries, which are basically the commands that the application uses to talk to the database.
Okay.
And by manipulating those queries, they can potentially bypass security measures and gain access to sensitive information, or even control over the entire database.
So it's like going to the library and instead of just getting the book you ask for, you somehow manage to get access to the entire card catalog.
That's a great analogy.
All right, so we've got all these attacks out there. How do developers even begin to defend themselves?
Well, for each type of attack, there are specific validation techniques that you can use.
Like, give me an example.
Sure. So one is called exact match validation, and that's where you basically have a predefined list of allowed values, and you just check the input against that list. Another is known good validation. This is sometimes called whitelist validation. And with that one, you're only allowing specific characters or patterns in the input.
Got it.
And then there's known bad or blacklist validation, and that's basically where you block any inputs that match a list of known malicious patterns.
So it's like a toolbox of different approaches?
It is. And on top of that, there are also tools like the OWASP Enterprise Security API, or EASE API, which is like a pre-built security toolkit that developers can use.
So it's like having a security expert built into your code editor.
Yeah,
That's amazing. All right, so we've talked about protecting data from the outside, but I know there's also a whole other side to this, right? Like, what about securing sensitive operations within the application itself? Things like authentication and session management.
Absolutely. That's a whole other can of worms.
Well, let's open that can in part 2 of our deep dive.
Welcome back. Ready to dig deeper into the world of secure software?
Absolutely. Last time we talked about protecting data from those external attacks, but now let's shift gears and look at what's happening inside the application itself.
Right, because even if you've built Fort Knox around your data, you still need to make sure the right people have the right keys, so to speak.
Exactly. And that brings us to authentication and session management.
So authentication, that's all about verifying someone's identity, making sure they are who they say they are.
Right, like when you log into a website with your username and password.
Exactly. The book talks about 3 main ways to do that. Something you know, something you have, and something you are.
So passwords, tokens, and biometrics.
You got it. But even those classic methods like passwords can have their weaknesses.
Oh, yeah, especially when you think about password resets. That's like a backdoor into the system if it's not done right.
Absolutely. I mean, you could have the strongest password in the world, but if an attacker can manipulate the reset process, they might be able to bypass all that security.
The book gave some scary examples of that, like systems that only require a user ID to initiate a reset.
Right. And let's not forget about those security questions.
Oh, don't even get me started on those. What street did you grow up on? I mean, come on, anyone can find that info online these days.
You're telling me. If those questions are easy to guess or the information is publicly available, they're really not providing much security at all.
It's like having a high-tech security system on your front door, but leaving a spare key under the mat. Speaking of leaving the door open, the book also talked about session management and how important that is for sensitive transactions.
Oh, yeah, huge. I mean, think about online banking. You wouldn't want someone to be able to, say, transfer money out of your account without having to re-authenticate.
That would be a nightmare. So session management is basically making sure someone is who they say they are throughout their whole interaction with the application.
Right. It's not enough to just check their credentials once at the beginning. And one way to beef up security here is through account lockout mechanisms.
Oh yeah, like when you type your password wrong too many times and suddenly you're locked out.
Exactly. It can be annoying, but it's a simple but effective way to prevent those brute force attacks where someone just keeps trying different password combinations until they get lucky.
Makes sense. So what about multi-factor authentication? I hear that term thrown around a lot, but I'm not sure I fully understand it.
It's a great way to enhance security by basically requiring users to provide more than just a password. Think of it like this. You have your house key, but you also have a security system with a code. You need both to get in.
So it's like double locking your digital door?
Exactly. It makes it much harder for an attacker to break in, even if they do manage to steal one of your credentials.
Okay, so we've covered passwords and sessions, but I know there are more ways for attackers to try and sneak in, right? The book mentioned this thing called cross-site request forgery, or CSRF.
Ah, yes, CSRF. This is where things get really sneaky.
Yeah, give us the lowdown. What is this CSRF all about, and how does it work?
So imagine you're logged into your bank account, right?
Okay.
And then you go to another website, let's say it's, a harmless blog about gardening or something. But hidden within that blog's code is a malicious request that targets your bank's website using your active session.
Wait, so I'm just browsing a website about flowers, and suddenly money is being transferred out of my bank account.
That's the danger of CSRF. It basically exploits the trust that websites have with the user's browser. Since you're already logged into your bank, your browser will automatically send your credentials along with that malicious request. So the attacker is able to do things on your behalf without you even knowing it.
That's scary. So how do you protect against something like that?
One common technique is to use multi-stage forms, where you basically force the user to confirm their intent before performing any sensitive actions.
It's like that, "Are you sure you want to delete this file?" message you get on your computer. Little sanity check.
Exactly. Another approach is to use random tokens, which are unique, unpredictable values that get generated for each user session. These tokens are embedded in forms and requests, and the server will verify those tokens to make sure the request is legitimate.
So it's like a secret handshake between your browser and the server.
Yeah, that's a good way to put it.
Okay, so multi-stage forms, random tokens, got it. Now, we talked a bit about cookies before, but I think it's time to dive a little deeper into those and also session IDs.
Cookies can be tricky little things. Remember, they often store sensitive information, like session IDs, which are used to track your session on a website.
And if someone steals your session ID, it's basically like they've hijacked your account, right?
It's not a good situation. That's why it's so important to protect those cookies. One way is by setting those secure flags, like HTTP only and secure.
Remind me what those do again.
HTTP only prevents client-side scripts from accessing the cookie, making it much harder to steal through cross-site scripting. And the secure flag ensures that the cookie is only transmitted over a secure connection, like HTTPS.
So it's like putting those cookies in an armored truck.
And then when it comes to session IDs themselves, you want to make sure they're random, unpredictable, and really hard to guess. Think long, complex strings of characters.
Makes sense. You don't want someone just being able to guess your session ID and take over your account.
Exactly. And it's also crucial to protect those IDs during transmission, when they're being sent between the browser and the server.
Encryption is key here, right?
Absolutely. And don't forget about setting those timeouts. You don't want sessions hanging around forever if a user forgets to log out.
Like leaving the door unlocked after you leave the house. Okay, so we've talked about protecting data from outside attacks, and now we've covered some key strategies for securing sensitive operations within the application. But there's still one more big piece of the puzzle, right?
Right. We need to talk about access control, making sure the right users have the right permissions. That's what we'll be diving into in part 3.
All right, welcome back to the deep dive. So we've talked about protecting data from the outside, securing those internal operations, and now we're ready to tackle access control.
Yeah, this is where we make sure that only the right people have the right access to the right resources.
So it's like, the bouncer at a club deciding who gets in and what they can do once they're inside.
Exactly. The book talks about the principle of least privilege, which means you only give users the bare minimum access they need to do their job and nothing more.
Makes sense. Don't give anyone more power than they absolutely need.
Right. It's all about minimizing risk.
Now, I know the book also mentioned this idea of security through obscurity, which always sounds kind of counterintuitive to me.
Yeah, it's this idea that you can keep things safe by just hiding them. Right. But in reality, that's not a very effective strategy.
So it's like thinking your house is safe because it's tucked away on a quiet street.
Exactly. A determined burglar will find a way, no matter how well hidden you think you are.
So it's better to focus on strong, transparent security measures rather than trying to hide things.
Absolutely. And speaking of sneaky ways to get in, the book also talks about these parameter manipulation attacks.
What are those?
So basically, attackers try to tweak the information being sent from the client side to bypass security checks.
Can you give us an example?
Sure. Imagine a website that uses hidden parameters in the URL to control access to certain pages or features.
Okay.
If an attacker can figure out how those parameters work, they might be able to manipulate them to gain unauthorized access.
So it's like trying to pick a lock.
Yeah, it's kind of like that.
All right, so it sounds like it's a constant back and forth, right? Developers trying to build secure systems and attackers trying to find ways to break them.
It is. It's a constant cat and mouse game.
Yeah.
But there are ways to build those robust access control systems.
Like what?
Well, one key strategy is role-based access control. You define different roles with specific permissions, and then you assign users to those roles. That way, people can only access the things they need to do their job.
So it's like those colored badges you see in some buildings, granting access to different areas.
Exactly. And it's also important to enforce those permissions consistently throughout the application.
No shortcuts.
Right. Every interaction, every request should be checked against those permissions. And it's also crucial to have a deny by default policy.
So if someone doesn't explicitly have permission to do something, they're blocked.
Exactly. It's like a fail-safe mechanism.
I like it. So you're saying err on the side of caution.
Always. Especially when it comes to those administrative interfaces. Those are the crown jewels, They give access to the most sensitive parts of the system.
Yeah, it's like having the master key that unlocks everything.
Exactly. So you need to be extra careful with those. The book recommends a layered approach. Strong authentication, maybe even multi-factor. Restrict access by location or device.
Like a high security vault.
Exactly. All right, I think we've covered access control pretty well. Shall we move on to cryptography?
Ooh, yeah. That's one of those words that always makes me feel like I need a degree in computer science to understand it.
It sounds intimidating, but it's really not that complicated. Cryptography is essentially about protecting information and communications through the use of codes.
So it's like a secret language?
You could say that. And one of the key techniques in cryptography is hashing, which is especially important for password security.
Right, because you wouldn't want to store everyone's passwords in plain text, right?
Yeah, it would be a disaster.
Hmm.
Hashing basically transforms those passwords into unique strings of characters that are virtually impossible to reverse engineer.
So instead of storing the actual password, you store this scrambled version of it.
Exactly. But even hashing has its weaknesses. There are attacks like dictionary attacks and brute force attacks.
How do those work?
So dictionary attack is basically where an attacker takes a list of common words and then hashes them, trying to see if any of those match the stored hashes.
So they're not actually trying to crack the code, they're just trying to guess the original password.
Exactly. And then brute force attacks are even simpler. They just try every possible combination of characters until they find a match.
So how do you make hashing more secure?
Well, one technique is called salting, where you add a random value to the password before hashing it. This makes it much harder to use pre-computed tables of hashes.
So it's like adding a secret ingredient that only you know.
That's a great way to put it. And then there are also keyed hashes, which use a secret key to generate the hash, adding an extra layer of security.
Got it. Now, the book also talked about using well-vetted, publicly available algorithms for cryptography. Why is that so important?
Because those algorithms have been tested and scrutinized by the best cryptographers in the world. They're considered the gold standard for security.
So don't try to be a hero and come up with your own encryption algorithm.
Exactly. Stick to the tried and true solutions.
Good advice. And the book also had a note about randomness in cryptography.
Oh yeah, that's a big one. For a lot of cryptographic operations, you need truly random, unpredictable values. And that means using something called a cryptographically secure random number generator, or CPRNG.
So not just like picking numbers out of a hat.
No, definitely not. You need a system that can generate true randomness. And with that, I think we've covered pretty much everything from the book.
It's been a whirlwind tour of the world of secure software development, that's for sure. We've gone from the basics of input validation all the way to the complexities of cryptography.
And it's clear that security is a multifaceted challenge, right? There's no silver bullet. It's an ongoing process of identifying and mitigating risks.
And it's a process that everyone needs to be involved in, right? From the developers building the software to the users interacting with it.
Absolutely. The more we understand these concepts, the safer we'll all be online.
And that's what the deep dive is all about, equipping you with knowledge. We hope you've enjoyed this exploration of secure coding practices. Until next time, stay curious and stay safe.